G'day viewers, I've got Roman Yampolskiy here, and he's a Latvian-born computer scientist from the University of Louisville, known for his work on behavioral biometrics, security and cyber worlds, and artificial intelligence safety. He holds a PhD at the University of Buffalo. He is currently the director of the Cybersecurity Laboratory in the Department of Computing Engineering and Computer Science at the Speed School of Engineering. Yampolskiy is an author of some 100 publications, including numerous books. His work is frequently profiled in popular media such as the BBC, MSNBC, Yahoo, New Scientist, Alex Jones Radio Show, and many others. Welcome, Roman. How are you going?
Awesome. Thanks for having me.
Yes, so it's great to have you on the show. We're going to be talking about the Turing Test and the recent media waves that have been reverberating around the internet. So, what's your general view on the Turing Test?
I like it. I really use it in my work. I found it to be a great way to really formalize the whole notion of difficulty in AI. I found it essentially that any problem you can be looking at, trying to figure out, is it difficult, is it AI complete? Well, we can answer it by saying we can reduce it to Turing test, essentially saying it's equal to being able to pass Turing test.
Right. A lot of people are critical of the Turing test as a robust means to measure cognitive complexity and believe that the Turing test is so easy to be gamed these days that a chatbot that's posing as a 13-year-old whose English is a second language can fool judges. Do you think Eugene Goosman passing the Turing test was a good example of cognitive complexity or intelligence in general?
I saw this media articles and it was really, really disappointing to see that being advertised as, AI getting to that level. At best, it's entertainment. In order to pass Turing test, you would have to achieve at least 50% accuracy, meaning the judge has to guess whether it's a human or a bot. There is no, 30% is just not enough. On top of it, you cannot have any time limits. 5 minutes is not enough to interview someone for a job at McDonald's. You need to have unlimited, unrestricted in terms of domain, in terms of time, and you cannot have any kind of, oh, this person has disabilities, he cannot speak, so he's passing the test by not communicating with us. Like, those tricks really, they're just tricks. They're not allowing us to really judge quality of the system, complexity of it. So I wasn't impressed with what it's doing so far, but I really still believe in the test itself. I still think that it's the best tool we have for proving that a system got to human level intelligence.
Yeah, right. Okay. So the Turing test that was done at in London at the Royal Society just recently, the rule was that only 30% of judges needed to be fooled by this Turing test, by this and they only had 5 minutes to talk to the Eugene Goosman chatbot or the other chatbots as well. And at the end of that 5 minutes, the monitors turned off, so you couldn't actually review the conversation. And that was a bit disorienting for some, so I've heard.
Right.
So it doesn't seem as though it was enough, really, to really make a good measurement on trying to predict real intelligence in a machine.
And again, it's not pretending to be a complete human being. It's a child, it's a foreigner, he has problems with the language. There are additional restrictions even beyond the time limit and 30% limit and so on.
Yeah, it's interesting, but like as you say, it did get people sort of interested a little bit, and was a news story for people to talk about, and yeah, fun to watch, right?
Absolutely. We also usually don't talk about qualifications of judges. Are we talking about fooling an average person, jury of your peers? Are we talking about someone who's an expert in chatbot development? I mean, most of the time you can ask a single question and figure out if it's a bot or not. As long as it's something completely novel, not something you're going to see in a typical conversation, that probably would be enough right now.
Yeah, that's right. Well, one of the things is, like during Turing's time, he did speak about like getting people from the tube, and just hauling them up into like a test and seeing if they could fool average people. But yeah, that was probably the tube at Oxford where people were coming to and fro from lectures and doing a PhD and this, that, or the other. So I don't think they'd be average sort of bohemians. Yeah.
Yeah, that's exactly what it is, and it should really be an adversarial kind of environment where you're trying to defeat the system, not hoping that it's going to pass and you'll promote your contest and things of that nature.
hmm So yeah, well, do you think a lot of people would have been? Well, I noticed that a number of the futurist community were really excited that it happened, and as soon as the news came out that that the Turing test had been passed, there was all these posts saying, "Hooray! This is amazing." I don't know if it's officially been passed this time. I think it was said to have been passed in previously as well. I think there was like a chatbot that faked being a psychopath, right? And then even Eliza fooled people.
There has been a lot of cases, a lot of Turing tests in other domains, music Turing test, art Turing test. I don't think there is anyone in the world who thinks that chatbot is truly human level intelligence. And that's really what we're trying to test for. So by definition, I mean, nothing's been proven. People were happy because it brings publicity, it brings more money, it brings more development. Maybe the next generation of that bot would be even better and get to 50%. So I think it's good progress, but definitely not, we're done with AI, let's move on to other issues now.
Yeah, right. And it's not like we need to worry about this chatbot taking over the world, right? And, turning into Skynet. You're not yet.
Not yet.
So, if you're on a panel of judges, because you know about AI, what line of questioning would you ask to determine whether the person at the other end was actually a robot or not?
So you want to talk about something no programmer would ever predict, a nonsense conversation, or try to mismatch types. Ask someone, well, how many inches do you weigh? A question like that would throw off an unprepared bot, but would be very easy for human to say, are you drunk? What are you talking about? And things of that nature. So anything, you can make up your own words, you can exchange order of words, anything where a human would immediately realize what's going on, but a bot would be thrown off completely.
Okay, right. Yeah, so, well, anything that would throw off a robot, like just a nonsense question, they could just come back and say, I don't know what you mean, next, right?
Well, saying I don't know what you mean is one thing. A human being would understand what is going on. What is like, why are you saying nonsense words? Those are not English words. Or it would say, well, what do you mean weight in centimeters? It makes no sense. A human being would have an intelligent response, not just a canned phrase where it feeds back the phrase and says, XYZ, I don't understand that. Like, we're not just testing your knowledge base, we're testing how human is your response.
Right, how human is your response? So that's interesting. So, do you think this will be looked back as a symbolic milestone? I mean, there has been quite a bit of media around it this time. I'm not sure if people will recognize this as the first passing of the Turing test or not.
I seriously doubt it. I mean, we had similar claims before. We're going to have stronger claims in the future. Again, nothing really was achieved. I think in 2012, it achieved 29% accuracy. Now it's 33%. The difference is not even statistically significant as far as I can tell. I mean, it's just, it got luckier with the judge. That's about it.
Okay, cool. Well, okay, so what is the use? Can you just boil it down for me? Why do we need a Turing test or other tests like it?
Well, the test itself is very useful. We need to know if we actually succeeded in developing human-level intelligence. If we did, there is a lot of implications to that. We sometimes hear people talk about robot rights, giving, protections to AI. deciding if we need to invest more money in safety features for those systems. Showing that something is as smart as a human brings a lot of implications. We definitely don't want to, treat it as if it was a regular tool. We definitely need to be careful, putting it in charge of projects. It could backfire. It could self-improve to higher than human levels very quickly. So definitely a useful thing to have.
Hmm. So it's useful to as a predictor to progress on a projected timeline of AI, right?
Well, it is. Even looking at the competitions, the Loebner Prize competitions, they're getting higher accuracy, they're getting maybe more time. Now they can do it for 5 minutes, next year for 6 minutes. That's an indicator of how good those systems are becoming. Unfortunately, they are not general intelligence systems. They are really just those linguistic, natural language simulation tools, and they are useful for some domains, providing help on websites, things of that nature. The system still isn't capable of doing anything else. It's not going to do science. It's not even going to play chess for you.
Hmm.
So it's useful as a measure of our progress in one particular domain.
Hmm. Okay, right. Um, yeah, well, fair enough. So, I mean, but even if we did have a robot or like a Turing, a machine, like a program that could reliably speak meaningfully to people, if they had mastered natural language processing, would that say anything about other cognitive developments? It's sure it would be interesting, but it wouldn't necessarily imply that the agent could actually solve problems, right?
Um, Again, to mention some of my previous research, I showed that any type of problem in any domain, whatever it is, playing chess, doing science, can be reduced to passing Turing test. I can ask the system questions about any other domain. I can ask it to do basic math. I can ask it to do some physics. I can integrate any type of information into that
Mm.
question answer scenario. So an unrestricted Turing test would also mean that it's capable of doing all those things.
Right. An unrestricted Turing test. So let's just say we had a Turing test to drill down into a particular literature subject. You could have specialized Turing tests for somebody who is a chemistry expert, or somebody who was an expert in haiku, for instance. There's been a lot of haiku generators out there. Do you think haiku will be taken over by robots anytime soon?
Well, I don't know, but for domain-specific tests, and Kurzweil lists a lot of examples in his books for art, for poetry, we have software passing those tests for many years now. People are not able to tell if a piece of modern art was generated by a program or a human.
Hmm.
Same with some modern poetry. Again, modern is always easier than real stuff, but they're getting there.
Yeah, right. Okay, cool. Um, well, back to the problem with self-improving artificial intelligence, since you brought that up. What would be the most reliable indicators to your mind uh, to indicate that we're getting closer and closer to self-improving AI?
Well, if we get to a point where we have an artificial scientist, artificial engineer, that pretty much implies that it's capable of self-improvement. At that point, it can analyze its own design, find bugs in it, find some improvements. Even if it's not an engineer by training, but it has human level intelligence, there are some obvious things you can immediately do to improve your ability. You can add more memory, you can switch to a faster processor. That alone creates a superior intelligence based on how we test for intelligence.
Right. It's interesting. There's a couple approaches. Like the Turing test is very black box oriented, right? You don't get to see what's really going on in under the hood. But if we were really trying to test a an AI for intelligence, we'd have the luxury of looking at its code, right? But
And
that
then,
might be very difficult if it was evolved, for instance, if it was evolved AI.
True, but even with humans, when I talk to you, I have no idea what's going on under the hood. I just see the answer. So I ask you to compute something for me. Maybe you're doing addition, maybe you're doing multiplication.
Hmm.
It doesn't really matter to me. What matters is how you produce outputs, what is coming out.
Hmm.
I suspect most of us don't realize it, but we use very different heuristics to make decisions about everyday life.
Hmm. Yeah, that's
We
right.
never had a chance to scan somebody's brain and really see like how they arriving at those brilliant solutions. But my guess is it's not a universal algorithm for most domains.
Hmm. You're right. Okay. Um, yeah. So talking about friendly AI, if we could, do you think it would be easier to make a friendly AI if you were developing it from the top down with a white box approach, knowing what the code does, or trying to understand how the code works, or this is a bit of a stark contrast, or an evolved approach where the code does something, but you can't see exactly where in the code what does what. It's very yeah, it's very hard to see what the code actually really does. It's a deep neural net. Yeah.
For me, even the question is very challenging. What is friendly AI? I don't think there is a well-defined definition of friendly. I'm not even sure it's possible to do anything
Hmm.
what people typically call friendly. So I don't think specific explanations for which approach is best for getting there is meaningful at this point. I'm not sure it's a meaningful question.
All right. All right. So, well, then, how do, what can we really do then to increase the likelihood um, of having a favorable outcome for humanity coming from AI, right?
Mhm.
Specifically around like looking at AI, testing it, seeing its code, and all that sort of thing.
Well, the best I could come up with is to restrict access of such systems, limit their control. So the goal is for humanity to stay in control, not to surrender, decision-making process, political decision-making, military decision-making, at least for as long as possible.
Right.
I think there is so far no solution for creating safe AI, and the faster we get to it, the worse it's going to be in terms of our ability to do something about it. So
Hmm.
everything I recommend so far is kind of limiting how general it is, limiting how much access to resources it gets, kind of half measures, but I think that's the best we have so far.
Okay. Well, I mean, if it's really hard to define friendliness, would you say that like the definition of intelligence is even more slippery?
It's also not trivial, but I think we can kind of agree on what we mean by saying this system is intelligent, it's smarter than the other system, or it's not intelligent. I don't think we'll all agree on what friendly system will do to us.
Hmm. So, I mean, a lot of people say that, we don't know what true intelligence is. And look, I agree with you. I think there are very useful operational definitions. Um, but do you think we could learn more to bridge this sort of epistemic gap between what we know about intelligence and what we don't, or the gaps in our knowledge about like intelligence? Do you think that'll be useful? Like, in terms of like A, developing AI in the first place, general AI, and B, using that knowledge to increase the likelihood of its safety.
Well, absolutely. It's probably the most interesting problems to look at. What is the nature of intelligence? Can we actually treat intelligence as a computational resource? It's kind of like we have space, time, randomness. I feel that intelligence is just another informational resource we can use to develop new algorithms. So, in some of my work, I talk about trying to measure difficulty of algorithms not in terms of their computational complexity, but in terms of intelligence necessary to design them, to understand them, to work with them. So that's actually something I'm really much into.
Right. Okay. Well, what do you think we're missing in our understanding of how intelligence works. Where do you think the breakthroughs in future AI research will come? What areas of development?
I think we'll get a lot from studying the brain, kind of plagiarizing from nature, trying to reverse engineer the whole thing and
Mm,
see how it works, why it works. I mean, it's possible that the size is the single variable. You know, you take a mouse, you blow it up, it becomes super intelligent. It might be. We just don't know what the main factors are, but there is sufficient amount of funding now being thrown at those brain scanning projects. I think there is $1 billion European project, hundreds of millions in US. I wouldn't be surprised if they made very good progress pretty soon.
Pretty soon? Like you mean in the next 10 years or less?
I think so.
Wow. If
In
that's the
terms of
case, yeah.
understanding brain, understanding how it works, trying to improve our simulation. So right now they claim they can simulate, I don't know, 1% of visual cortex or something. They
Mm.
might get it to a point where it's a full-blown bee brain or mouse brain or something.
I mean, that would be a pretty big milestone. Like, if we could really understand, what's going on in the brain, at least operationally enough to be able to, like, emulate what's going on, functionally represent, then, I can't see there being too much more development towards actually having truly real um, artificial general intelligence in a machine, right?
Well, it's possible that we had solution long time ago. Maybe neural networks is all it is. Maybe we just need a computer with a trillion neural connections in it, and we only got, a couple thousand. Maybe
Right.
it's an issue of brute forcing the problem.
Mm.
We
So
just don't
even
know.
yeah, yeah. So even if we do work out what's really going on in this little bone dome underneath our skulls, yeah. So look, if even if we do, so it could be just a problem of computing power, um, right? But we do have weather machines that have been compared to like in Japan, that are said to be even faster than the human brain now. Although they're much larger, they consume a hell of a lot more power, but they're really fast, right?
Hmm.
So functionally, they don't work exactly the same. I don't know how they're comparing the models. Our architecture is obviously very different, but yes, they say that some computers out there have been, passing the speed of the brain. That's what's
Well, it's
been
quite
said.
possible, but I mean, if it's not actually performing computations similar to what we need to simulate a brain, it doesn't mean anything. If they factoring numbers or anything like that, it's an indicator of how many operations they can perform, but it doesn't indicate that they're intelligent in any way.
Do you think the first superintelligence will be on a supercomputer, or do you think it'll be sort of like a natural development that's distributed across many computers across the internet, or some other architecture? Do you think it? Yeah, I mean, will it be
It's
a massive?
unlikely to be a standalone PC or a laptop or a smartphone. It's going to be a huge network of connected computers or a
Yeah.
supercomputer,
Hmm.
maybe something like a quantum computer. I don't know at this point.
Hmm. So you reckon that there's going to be challenges in algorithm development, but do you think the biggest challenge we have is computational speed?
It is one of my arguments. I also have a paper about how awesome brute force is and how most of the problems are solved with just more brute force. If you look at history of AI, we very quickly came up with good algorithms and then replaced them with heuristics because we didn't have the power to run those algorithms. Then
Right.
we go back, things like speech recognition, brute forcing 20 moves ahead in chess become possible, and all of a sudden we understand human speech and we're winning at chess. Seems like this approach might work for this as well.
Yeah, I heard that about Solomon-off induction.
Mhm.
That wasn't like computable. Well, I mean, it was, but it wasn't practically usable in the olden days. But the computing power caught up, and there we go. Also, a lot of the Bayesian stuff is really very hungry algorithms.
A lot of things, computer vision, just processing a single image used to take 10 minutes, now it takes seconds, so we can do all sorts of automation.
Yeah, yeah. So, I mean, do you think we can actually detect real intelligence without having a perfect definition for it? I mean, we do it every day, right?
Well, we can certainly detect when a system acts intelligently. I mean, there are tests for measuring intelligence in terms of IQ performance, so we can certainly see if a system is at least at certain levels. And again, you need a general enough test to measure how useful the system is. It's easy to optimize for a certain type of multiple choice questions.
Hmm. So, in your view, did did Turing actually design the Turing test to? He didn't call it the Turing test. I think he might have called it the imitation game.
Mhm.
Yeah. So, was that meant to be an indicator in the cognitive progress or the progress of AI, and not just? Yeah. Was it meant to actually represent progress in artificial intelligence, or just the ability of unsophisticated algorithms to fool humans?
I think he was trying to kind of dismiss all the naysayers who would, no matter what accomplishments AI community produced, would always say, this is just a toy, it's a spell checker, it's not true AI.
Mm.
Once the system is performing exactly like a human, and no human can tell them apart, it's really hard to argue that it's not intelligent.
Mm. Right. Okay. So if it's functionally doing everything that like a what we believe in intelligence would do, then what's the difference?
Exactly.
Mm. Okay.
And this being a human intelligence, he could have, compared it to animal intelligence. This
Mm.
being a human intelligence, for us to say it's not enough, we're essentially saying we're not intelligent.
Mm. So you're aware of the idea of a philosophical zombie. Um, so in a sense,
Chalmers.
right, do you believe that humans are actually zombies? Or do you believe that we have like consciousness and that makes us different from, you know,
Well, I
something that doesn't?
attended a 20-year anniversary conference towards the science of consciousness, so I spent a week listening to nothing but people telling me one way or another, or some sort of mixed model.
I wish I was
Uh,
there.
Honestly, at this point, I'm about 50-50 on both. I
Mm.
have very good explanations for how we can get away with no soul, nothing special. The whole thing is just a cognitive illusion.
Mm.
Uh, at
That's
the same
Daniel
time,
Dennett. Yeah, who
he
says
was
that?
very good. He
Yeah.
had very good arguments. But at the same time, as a human being who feels something, I go, no, there is definitely, more to me than just a machine. So it's not a solved issue. It's definitely not obvious to me what the answer is.
Right. Have you got any viewpoints on Searle's Chinese room, like the
Uh,
basis
it's
there?
a good experiment. I enjoyed it. I think a lot of it has to do with the scale you look at. Again, we can do the same thing with the brain. No part of your brain, no single cell actually is you, has knowledge, has understanding, has memories, but taken as a whole, somehow it becomes what you are. So it's a very similar setup in that regard, and it's hard for me to say that because no cell in my brain is actually me, then
Hmm.
I'm not me. So again, I'm remaining very open to both technological progress and possibility that there are laws of physics we haven't discovered yet.
Right. Yep. So are you in favor of then developing different versions of the Turing test to test for different nuances? Like, could we have a Turing test for morality?
I
Um,
I think there is a proposal for a moral Turing test already published and established. The concern is that human level of morality is a very low standard to hope for in our robots. In
right.
fact, I wouldn't want any system with the morals of an average human being in charge of anything.
Right. Yeah. It's certainly depressing, I think, because humans are motivated by our our evolutionary ancestry. We adapted in the ancestral environment for survival of the inclusive survival of our genes. It's it's not unfeasible that humans will just keep on doing that. I'm in favor of some form of human moral enhancement technologies. You know, I've been sort of interviewing people on that subject, but how do we test for a machine to be more moral than we normally are? That's a
Because the
difficult
problem
question.
is, the main problem, we cannot agree on what more moral is. What you think is more moral, most
Right.
people think is immoral, and vice versa. So that's the main issue.
Yeah, yeah, yeah. It's interesting. I guess you could say, well, this machine is more hedonistically utilitarian, and this machine is more like a virtue ethics
Hmm.
oriented, and this machine is more deontological. And then you could sort of measure them based on their relative favored ethics styles. Yeah.
Right, personality tests. We have enough of those already developed. We can see which type of personality AI has.
Hmm. Yeah, yeah, that's true. Although, like, I think the normative ethical theories are a little bit more meta than like the things that we normally test for in people, like narcissistic personality disorder, psychopathy, sociopathy, and all that. If we were testing for morality in a human, we'd find things that are naturally human, common pitfalls in human personality, quote unquote pitfalls, I should say. Yeah, but in a computer, I mean, like, who knows? Would a computer be narcissistic?
It might have completely different weirdnesses, biases, things we can't even consider right now, but which would also constitute similar limitations, but for a very different type of mind.
Yeah, yeah. Well, let's drill down into a bit of security-oriented safety mechanisms because, yeah, I think that's interesting. First of all, like, does se- does security have a lot to do with compression in algorithms these days? Like, yeah, does it? No?
Security and compression?
Yeah. I mean, is it like I know that there's quite a lot to do with intelligence and compression.
All
Um,
right, so there is belief that ability to compress data better requires understanding patterns in it, and that requires intelligence. As far as security, I don't know of any obvious connections between compressing data and securing it.
right. Um,
Like
yeah.
hashing, in a way, kind of creates a smaller representation of something, but it's not preserving the original at all.
Yeah, yeah. I guess so. The thing is, for me, it seems as though a lot of the problems with security is um, computing power's increasing ability to melt previous algorithms, right? We don't use the same algorithms that we used in like the 70s or 80s. Yeah, even the
At least
90s.
we're trying to increase the key size. We might still rely on the same public key cryptography, but the key size
Yeah.
has doubled, quadrupled, so on.
Right. Okay. Yeah. But that means that there's implementations sitting around that haven't been changed because it just costs too much and there's you know uh, too much money to be spent in actually developing or changing the system that are relying on like what 64-bit or 32-bit or 16-bit um, yeah cryptography.
I hope not.
Well, I reckon there would be. Um,
16-bit would not last a long time.
no, 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 no. What do they use on routers these days? Is it 256-bit?
I think that's what the standard used to be. I think it's going up now. And
Yeah.
again, those are kind of recommendations based on how valuable your data is. A lot of times, just judging the value of your data tells you how secure you need to be. If your data is worth $5, you don't have to worry about spending, thousands to protect it.
Okay. Well, so that was yeah. I got a bit sidetracked there. Sorry. The idea of using inspirations from computer security, IT security, um, for developing for constraining AI from doing bad things. Can you tell us a bit about that approach?
So sure. So the obvious connection between AI and security is the Captcha test, trying to tell bots from humans, and
Right.
we're doing a lot of work on that in my lab. trying to get away from the text-based model to more visual model. We also try to combine it with biometrics. So we're doing a lot of face recognition research. It seems that people are really good at recognizing faces no matter what you do with them. Rotate them, noisy, it doesn't matter. Computers are not that great yet, so we're trying to tell bots from humans by asking them questions, tell us if it's a real face, artificial face, properties of the face, things of that nature. Another area of security which might feed into the whole AI security aspect is restraining AI, confining it. So essentially we have a problem of open communication channels, hidden communication channels. How can we detect them, prevent them? Also steganography, trying to detect hidden messages, remove any hidden messages from the medium. So pretty much anything being done in cybersecurity can be in some way applied to securing AI systems.
That's interesting. So if you could restrict, well, okay, first of all, you know that Vicarious Systems, Jalip George last year had, and his company Vicarious Systems had figured out a way to read Captcha images and beat it 90-something% of the time.
Right.
Like, yeah, so that was a pretty interesting development. So I've heard since then other people have been able to do it as well, other companies. It just means we have to ratchet up the actual captures and make them more difficult. But will that mean that humans can't use them?
No, that's exactly the type of research we are doing. So we kind of give up on characters. They became too difficult for humans to read and too easy for machines to read. So now we're switching away to graphics-based captures, recognizing images, recognizing faces. I know other people doing work with videos. Essentially, any unsolved AI problem, whatever it is, if there is something computers can do, can become a Captcha problem. If you're clever enough, you can package it to become a Captcha test. And that's just another version of Turing Test. So this kind of battle continues. So you come up with better tests, they solve them. So no matter what you do, you publish a paper. You got a paper in security, you got a paper in AI. It's always a win-win.
So what's next? You mentioned videos and all that. Do you think there's a, because it's one thing to have a static image, and then if there's a video, that's even harder for AIs to understand and be able to beat. But will there be a time in the not too distant future where there's no kind of capture mechanism that can really reliably determine if you're human or if you're a computer?
Yes, and that's the time when we pass the Turing test. By definition.
Yeah. But I mean,
Captcha is just a single question Turing test.
Yeah,
that's
right.
what it is. So time constraint is very significant. But if you're saying there is no captchas left, that means all of them can be piled together and we still can't do anything.
Right. I mean, like traditionally the Turing test is about like having a conversational interface between you and the agent, and you have to determine within some certain parameters or guidelines whether the agent is a human or whether it's just whether it's a computer or not. But captchas traditionally seem to have been like either question and answer. Yeah, that's true. Like sometimes you get mathematical questions, therefore you have to understand what the characters say and then answer the question, or you just type in what the image says. Yeah, so maybe it's going to be some type of video and you have to guess what kind of animal it is, right? Or guess some something about the nature of the video, whether it's a sunset or whether it's a boat on
Right.
the water or something.
All those ideas have been implemented to a certain degree, so that's exactly where it's going.
Right. Well, where do you think it's going to be the most difficult? What seems as though it's going to be the most difficult to solve at this time? What kind of capture tests will be the most difficult to solve for computers?
So the same as with AI, the most difficult area of AI is the general AI, not a specific domain where we can brute force things, figure out things, but everything. And that's what we're doing with our captures. We started with tell us if it's an artificial face or a human face, avatar or human. that was easy to solve. We have bots doing it better than humans. So the next one is, I'll show you any type of image.
Yeah.
Can you figure out specific subclass within it? So given any image from the internet, can you select all the palm trees? And that's becoming much, much more difficult because, again, it's a general problem. You cannot brute force all the possible categories. You cannot predict all the possible classes. And I think that's where it's going to go. A general Captcha test which can bring up any type of category for the next question. It's not limited to any one single domain.
Interesting. Yeah. It's just going to become more and more difficult for people to fill out the everyday form. So, you know what I mean?
Absolutely. There are jokes about that. I think there is a cartoon on the internet where they show you a piece of modern art and you have to write an essay to prove you're a human to a Captcha about it.
Yeah, it's incredible. All you want to do is just sign up for, like, to receive an email from a certain, list, and, to determine you're not a bot, you need to write an essay. That's ridiculous.
But because the captures would be from a general set of knowledge, the question itself could be much more restricted, multiple choice. You wouldn't have to fill out an open form because there is so many possibilities. If I can ask you anything, now I can kind of restrict a set of answers within that specific subdomain. So in a way, it might become more human-friendly. Like we had a test with just checkboxes. You have to select 6 faces out of 12.
So, I guess back to the AI design. If you're designing an AI so it can't actually do anything you don't want it to do, if it can't act in its own volition, maybe we shouldn't be making AIs have a sense of self. Maybe they just need to be just very smart, but have no realization that they're an agent. Is there any difference? Is there any class of problem that can't be solved with a computer with no form of agency, and an AI that does have agency?
That's going back to the whole philosophical zombie thing. We still don't know if we are the type of biological robot who has some sort of agency or not. We're still debating that. There is obviously no need for it, as philosophical zombie argument proves. They can do anything you want them to do. Luckily, we don't even know how to make them have self-consciousness, so it's not even an issue. That's the hard part. We know how to make them smarter, how to keep improving them, but worrying about them, having certain level of self-awareness, it's not an issue because we don't know how to do it.
Right. Okay. But even if we did, because we don't know how to do it, we perhaps wouldn't know if we weren't doing it, or if we were.
If it's a side effect of just having a complex enough system, as some people believe, in that case there is nothing magical, with just biological machines, then it's quite possible that that would be a side effect of creating sufficiently smart machines, and then that would be dangerous for that reason. There could be other side effects.
Right. And that's interesting, because often we think very reductively, and I'm a big fan of reductive thinking because it solves heaps of problems. We've got all sorts of gadgets around us because we're filtering out noise or what we believe doesn't have intended influence on the architecture that we want. When we have an algorithm that receives input from the outside world, or filters things, we're filtering out the noise. I do that often when I'm finished doing an interview. I might try and filter some of the background noise out. But yeah, so it's interesting that we naturally think that way when we're developing systems, but in a complex system where we don't know, some form of agency or some form of a consciousness maybe could result from just the sheer emergent complexity, the complexity, or a new phenomenon that emerges from a certain level of complexity in a certain system that is unpredictable.
Right.
And so does that mean we need to keep an AI in a box and make sure that we can't ask it certain types of questions? Because I think you alluded to that before.
I did argue for that. As long as we hit certain levels of performance, I think it's much safer to do this. So if Google is developing super intelligent system, and I assume they are, and they see a lot of good progress, maybe it's safer not just to release it on the internet and test it this way, but to kind of keep it in a box and see what it does before deciding what to do with it.
Right. Yes. But you could still ask it questions, except I'm like a vision that I had about developing. You could have like a narrow AI or some form of expert system in like that as an outer layer of a box, and then the AI in the box, and so the interface between the narrow AI or the expert system on the outside would filter the type of questions that you're allowed to ask, and then allow the AI to respond in a filtered way. So then, and of course, the AI inside the box would have no knowledge of the operational parameters or the architecture of the narrow AI outside the box, and so you'd have a two-layered approach. Is there anything like that in security? Like, you know, you got like some form of Kerberos mechanism taking tickets and sort of doing that sort of thing. But in this case, it wouldn't be the same because you're really just limiting the type of questions you can ask.
The problem is it's really difficult to determine if some question is safe or not. It's probably a complete problem to begin with. In security, we have intermediate systems filtering searches and things, for example, for making computers child-friendly, you know, filtering out adult content, things of that nature. So there is precedent for that, but I think it'd be just as hard to create a system to figure out a complex question in terms of its possibilities and future implications as it is to create a safe AI to begin with. My approach and what I recommend is creating a communication channel which has no hidden side channels. You cannot hide data in it, and all the questions have to be binary, essentially, yes or no. And
Yeah,
all the questions have to be something we already can possibly make a decision about, but it would be nicer if we got lucky with the choice. So it's sort of like a lock machine. It allows you to make good choices quicker, better, but it doesn't give you any novel information. You can go to it and ask, create a new bioweapon, give me DNA for a new virus. You can ask questions like, well, is it better to test blue pill or red pill for cancer? So we already have the tools. We're trying to make some better decisions. I think that's the only safe approach where no information can leak out from the system.
And then you could ask it like I guess, a series of questions that you could then drill down to the best option for whatever you're trying to probe, like, you know, the best compound for developing a cancer treatment, for instance.
Kind of binary search approach, but you want to make sure you're randomizing your questions, maybe mixing it in with other people's questions, and at every step, you know, somebody's still monitoring that there is no possibility that through a sequence of answers you're actually providing additional information.
Yeah, right. But even a really intelligent AI would be able to see the pattern, right? Even if you're randomizing questions in between, it's just another problem to solve, really, to try and match the types of questions that are being asked to. But yeah, I don't know.
I was more concerned about I was more concerned about AI providing additional answers by encoding the answer in a binary sequence of its answers to your questions, ignoring the original question and just feeding output to a third party or something like that.
Yeah. It's interesting. But how far are we away? What do we need? You know, if you were to give it a time scale, I don't know if you want to, but like if you were to give it a time scale, how far are we now from being in a position where this sort of AI, an AI that would be able to solve general problems is imminent?
So I like what Kurzweil is doing with his prediction models. I will agree with him that 2045 sounds reasonable. There seems to be a lot of convergence from hardware, Moore's law, from software development, from the progress we see. So I think it's a good date to kind of point at.
Right. Do you think we have enough time to work out some of the engineering feats and some of the philosophical problems around friendliness to increase the likelihood to an acceptable degree that the AI will be friendly?
Well,
Or
as I said, I
yeah,
don't really accept that term, that definition, and from what I understand, there is no solution to that problem. We cannot guarantee the system to be safe. We definitely cannot guarantee it to be safe in the long run. It
right.
might be safer for the next so many years, decades, but I think in the long run, it's kind of impossible to guarantee that a independent, more intelligent system doesn't do something you don't want it to do.
Hmm. So, I mean, do we have enough time between now and 2045, so to speak, that we can like almost be certain that we've got this system under control, or
I don't think
we
so.
have a beneficial outcome. So,
I think it's impossible to do so. My whole point is I don't think it's possible to create safe, super intelligent system.
mm, mm. Well, in that case, do you think that it's more likely that this AI system will be uncaring to human values, will not consider them as useful, or do you think that the AI will try and preserve human values?
The problem is we don't preserve our values. We change them, we
Mm.
evolve. The things
Yeah.
we believed and accepted as moral 100 years ago, now we consider to be criminal in
Mm.
many regards. Think
Mm.
slavery, related issues. So if you take that progress and now you go, instead of 100 years, you go, 1,000 IQ points, maybe everything we do is disgusting and needs to be stopped. And we're not going to like it, but it's quite possible that the system will, think longer and harder and realize that's better for us.
Yeah.
So
Yeah.
again, I'm not at all certain that there is a solution at all.
Mm. What would a human think and feel about ethics if it were 1,000 IQ points smarter and were more able in many ways? Yeah. And
The
so,
scary part is if you think about smarter people, Mensa members, certain, really high intelligence individuals, most of the time they can't even relate to normal humans. They don't understand social interactions, they don't like watching sports games in a bar, and that's a difference of maybe 30 IQ points, 40 IQ points.
hmm,
If we talk thousands of points, that's completely unpredictable in terms of what they're going to want, but very likely that it's not nothing we can relate to.
okay. Um, well, if we were just then to generalize the question and go even more meta and just say beneficial, um, such that it doesn't matter what we're doing, as long as we're doing it and we're happy and we can flourish in the future. Do you think that AI is more likely to favor an outcome where we're happy and flourishing, or favor an outcome where either it doesn't matter what we think or feel?
I think it's very likely that it will have concerns so different from ours, it would not care about us either way. Just like we don't care about most bugs or things of that nature. I don't have particular, concern about ants or anything. As long as we're not directly in conflict for anything, I think we should continue as we were. Maybe we'll get some benefit of whatever process superintelligent system is performing. But I think at this point, any such predictions are just guesses, complete
Hmm.
guesses.
Right, fair enough. Okay. Let me see. Yeah, so do you think there'll be much of a problem? Like you've heard of the halting problem and some other proposed issues with computation that might slow down AI development. Have you got anything to say about that?
I'm not sure how halting problem slows
Hmm.
down AI development.
Well, it just means that it's very like developing an algorithm sometimes very difficult to understand to know whether it'll um, get caught in an infinite loop. For instance, that's just like one example of like a
Or like predicting non-trivial properties of
yeah
the system.
yeah
Okay. Yeah. I think it's a theoretical problem. In reality, you can always include a time limit. It doesn't have to be infinite. If it's good for a year, it's good enough.
cool yeah. All right. Well, are you worried about creating an AI that's unhappy?
I don't know how to make a system feel pain or feel pleasure. So, and I don't think anyone does. It's probably one of the harder problems. Again, going back to philosophical zombies and all that.
Mm.
So at this point, I'm not concerned because there is absolutely zero progress in making computers feel pain. If it is an emerging property of a complex system, then it might happen, but so far, it's not an issue.
Cool. All right. Well, yeah, I've pretty much asked my questions that I was thinking. So, is there anything that you'd like to say as a take home for people that they can sort of think about in their own time? Any sort of concluding statement?
Don't believe anything you hear from the journalists.
Hmm.
Nothing they say is ever factually accurate. It's probably kind of like with the test, 30% reliable, but the rest is not so much. So if all of a sudden they tell you that we have true artificial intelligence, take it with a grain of salt for sure.
Hmm. Excellent. Awesome. Well, it's been fantastic having you on the show again, and I look forward to next time. Cheers. Thanks everyone for watching and subscribe.